Hello everyone. Today in math, I'm going to be going over just a few of the extra practice problems that I asked you to work on today as we practice these triangle and angle properties for finding unknown angles. I'd like to go over numbers 4, 6, and 7 on extra practice pages 104 to 105 and just kind of step you through these problems to make sure you understand how to solve them and that you are writing your work down correctly so that I can follow it and that you're able to use all these angle properties to solve some problems here. So let's look at the first one. First problem in number 4, what do we have here? Well, we have a triangle, and notice it's a right triangle because we have that little box in the corner. And then this side of the triangle has been extended both ways to create two exterior angles. And we're asked for one of the interior angles of the triangle, angle QRS. That's what we need to find. So let's go back and think about all we know about triangles. Well, we know that every triangle, no matter what size and shape, all three of the angles add up to be 180 degrees every time. So we can use that property to help us solve for this unknown angle. Now you can tell that we've been given one of the three angles. Obviously, that's 90 degrees. So how can we find that angle? Well, we really can't find this QRS without finding what this angle is here. That will give us enough information to find this unknown angle. So how do we find this angle? Well, hopefully you'll notice that this is a straight line, and we have an angle right next to it on that straight line that's been marked as 150 degrees. So my property that tells me that all of the angles along a straight line equal 180 degrees is exactly what I can use to solve for this angle. Finding this angle is as simple as saying 180 degrees minus 150 degrees is 30 degrees. Okay, so that was pretty simple. Now I have two of the three angles, so I can find this third angle because I know that the whole is 180 degrees. That's the sum of all three angles in a triangle. And I can subtract the sum of the two known angles to find the unknown angles. Let's do that. So angle QRS is equal to 180 degrees minus 90 degrees plus 30 degrees. And when you use your order of operations, you don't have to, but it's helpful, nice to do if you can. You should get 180 degrees minus 120 degrees, and that gives you your answer of 60 degrees. So this unknown angle right here is 60 degrees. Solved that one. Okay, moving on. Let's move on to number 6. This is an interesting triangle here. So we're asked to find angle STZ, this angle outside of the triangle. Okay, so let's take a look at what we have here. We have inside the triangle, we're given two of the three angles. So we need to use the triangle to help us find this angle outside of the triangle. Why is that? Well, if you take a look here, this side has been extended. This is a straight line, X to S. And this side has been extended, YZ. So these two straight lines cross. And I know that when I have two intersecting straight lines, that the vertically opposite angles are equal. So this angle right here is vertically opposite the unknown angle that I'm trying to find. And I know that they're equal. So if I can find this angle, it's exactly equal to my unknown angle of STZ. So how do I find this angle? Well, again, here's your triangle, and the sum of all three angles of a triangle is 180 degrees. If I have two of the three angles, two parts, and I know my whole, 180 degrees, I can subtract the sum of those two parts from the whole to find the missing part. So this one's pretty straightforward, I would say. Angle STZ is equal to 180 degrees minus 60 plus 45 degrees. All right, I'm going to keep on going with my order of operations, and I should get 180 minus 105, which is equal to 75 degrees. So this angle is 75, which is absolutely equal to the unknown angle because they are vertically opposite. You can, let me just remind you, you can only have vertically opposite angles when you have two straight lines that are intersecting. Two straight lines. Okay, moving on to number 7. Number 7 is an interesting problem here. So we're asked to find angle DBC. Well, let's take always, look at your figure here, and, if you want to take your book and you want to twist it around, turn it around, look at it from different angles. Sometimes that can give you just sort of a different picture, and things can become more obvious when you look at it from different angles. So I have a triangle here, obviously, and note that this side is extended to form an exterior angle. This side has been extended to form two exterior angles. And what I'm trying to find is one of the exterior angles of the triangle. And it's, excuse me, angle DBC. This is what I'm trying to find right here. So how can I find that angle? I don't have any of the internal angles of this triangle. And, remember we said there are often a variety of ways to find the answer here to this, but I'm going to lead you through just one way here. Okay, so let's take a look at what we see and what we know. Okay, first of all, we know that this is a straight line. And let's go back to that property that all of the angles along a straight line equal 180 degrees. So here are two angles right here. One angle's been given to us, 100. So this angle right here has to be 180 degrees minus 100. So this angle right here, we could call it angle BDA, is equal to 180 degrees minus 100, which is 80 degrees. Okay, that's pretty simple. I got one of the angles of the triangle. Because remember, this is an exterior angle. And an exterior angle is equal to the sum of the two opposite interior angles of a triangle. So if I can find this angle and this angle, I can add them together to find out what the exterior angle is. All right, moving over here, I need to know what this angle is. So let's call that angle BAD. Okay, so how can I find angle BAD? The same way that I found angle BDA. These are two angles along a straight line. They must equal 180 degrees. This is 140, so this angle is going to be 180 degrees minus 140 degrees, which is 40 degrees. Okay? Now, right here, my unknown angle, which is DBC, it's an exterior angle. Why is it an exterior angle? Because this side of the triangle, that straight line, has been extended. And so this angle, my property tells me that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. This angle is not an opposite angle. It's the two that are across from it. So all I have to do is add up this angle, and that gives me this one. So 80 degrees plus 40 degrees is equal to 120 degrees. So my unknown angle is 120 degrees. Is that reasonable? Yes, that is obviously an obtuse angle. So what would this, we're not being asked this, but what would this angle be? Well, that angle would simply be, that third, unknown angle of a triangle, would simply be 180 degrees minus 120 degrees, which is 60 degrees. And you can kind of do a check and say, okay, now I have all three. I wasn't asked to find that. I'm just pointing this out to you as we, look at the problem. Now we have all three angles of the triangle. They better add up to 180 degrees, or I have a problem. I've done something wrong. So 60 plus 40 is 100, plus 80 is 180. So yes, that answer is correct. That's kind of a way you can do a check. All right, so that was one way you could solve number 7. What I'd like for us to do is when we meet on the WebEx meeting on Thursday, I'd like for us to go over numbers 8 and 9 together. Those are, I would say, particularly challenging problems, but really a lot of fun and a great way to just put together all of this knowledge of angles and triangle properties. So we'll do 8 and 9 together during the WebEx meeting. If you can't attend that meeting, I'll be glad to post those solutions, and you can, try those on your own and double check your work. But in the meantime, we'll meet again as we work on triangles and unknown